Good morning, everyone. In the previous class, we have discussed about GIS and different types of electronic measurement devices in surveying. So in this class, I would like to explain the concepts about map, map projections, and data entry and its importance. Along with that, we are going to discuss the applications of GIS in civil engineering. So these are the concepts we are going to cover. So let us start the class. Map. What is a map? A map is a representation of irregular Earth surface on a two-dimensional paper. Actually, the Earth is a three-dimensional structure, uh, structure which we represent in two-dimensional paper, which is called a map. Concept of maps is a prerequisite for the students of GIS, as maps constitute the basic fundamental input to it. So this is about map. We'll see what are the different types of maps available for usage. So there are road maps, cadastral maps, topographic maps, and satellite images. These are the different types of maps available. Road maps, cadastral maps, topographic maps available with Survey of India, satellite images. These are all two-dimensional maps. So reference maps given general information regarding the location of geographical features. For example, topo sheets, atlas maps, etc. These maps will give us general information about the geographical feature at that place. We have already seen the different topo sheets and atlas maps. So these are the examples for reference maps. We have thematic maps. So thematic maps means it presents the distribution of a specific topic, like uh, uh, the amount of rainfall in a given area, how it is distributed across the given uh, city, or something like that. This will give the specific information of an area, like seismic zones. What is the amount of uh, uh, what is called? So thematic maps also gives different seismic zones, gradation, etc., depending upon the earthquake uh, frequency. So we can divide different zones into seismic zones. So it can be represented in thematic maps by different colors like that. So if we are talking about specific distribution, so here we will use thematic maps. So here we'll have a concept map accuracy. How long a map is accurate. So we have accuracy of location and accuracy in terms of attribute. Resolution means how many times it is resolution is giving the picture. Logical consistency, consistency with time, comprehensiveness. These are all the things we need to cover under map accuracy. The object of surveying is to transfer the details on the surface of the earth correctly to a sheet of a plain paper. So here we will do some survey regarding different features of earth, and these features have to be transferred on a two-dimensional paper. If the surveying area is too small, it is called, it means we are neglecting the curvature of the earth. It is called plain survey. Where the surveying is extensive and the area is also very large, then we cannot neglect the curvature of the earth. Here we have to consider curvature of the earth. Hence some kind of distortion of details in shape, area, direction, measurements, etc. become inevitable. So in such cases, we need to consider curvature of the earth, and in drawing, there may be a possibility that there is a distortion in detail, shape, area, direction, measurements, etc. Criteria for preparing an ideal map. So what is the criteria we will undertake? All distances and areas on map are exactly same as respective ones on the earth. This is the first point. So if we compare the area on the map and the actual area, this should not be any difference. This should be same. The distances as well as the area on the map are exactly same as respect to ones on the earth. So here we will take some scale. According to the scale, if we measure the areas and map, the areas and distances should be same in map and respective earth surface. All angles and azimuths are the same as on earth. So here angles and azimuths are also same. All great circles on earth appear as straight lines on the map. So great circles on the earth appear like a straight line because we are drawing on two-dimensional paper. If we enlarge it, if we enlarge a circle, we will get a straight lines. All the points on earth are correctly shown on the map in their longitudes and latitudes. These are the criteria. And map projection. What is a map projection? A map projection is defined as a systematic arrangement of intersecting lines on a plane that represent the datum surface. This is a map projection. Map projection is defined as a systematic arrangement of intersecting lines on a plane that represent the datum surface. Here we can see some of the map projections. Map projection for this flattened surface, conic surface, cylindrical surface. If you intersect these lines on a plane paper, we will get these surfaces. Depending upon extent of area involved in the nature of use of map, map projections are classified into conformal projections, equal area projections, equidistant projections, and azimuthal projections. So this classification is based on amount of area involved in the map projection. I again repeat, the conformal projections, equal area projections, equidistant projections, and azimuthal projections. Conformal projections. It is also called as orthomorphic projections. Local shape of the surface is correctly represented. Here, if we observe, the local shape will be as similar to the original one. Small areas appear in correct shape. For large areas, shape distortion is there. Used for if we do for this is suitable for smaller areas. If you go for larger areas, there might be a shape distortion. It is used for preparation of navigational maps and weather charts. This is an example for conformal maps where it shows some weather details of an area. Then equal area projections. These are also called equivalent projection method. Area is correctly represented for displayed features. In this equal area projection method, the area of the actual feature is correctly represented and it is displayed in the map. Shape, angle, scale, or any combination of these may be distorted. So if you observe for the area is same for the actual feature and the map. But if we observe shapes, angles, scale, or any combination of these may be distorted. Used in This is used in maps for representing areas at mid latitudes with extensive east-west dimensions. So this is a special case where equal area projection method is used. Here we can see the example for equal area projection method. Here the area may be same, but the shape, size, these may be a little bit distorted. Then equidistant projections. Distances are correctly represented between certain points. Scale is also maintained along one or more lines. It can be cylindrical, conical, or azimuthal. So the name itself suggests us that distances are correctly represented between the map, between the certain points on the map. Scale is maintained along one or more lines. It can be cylindrical, conical, or azimuthal. So this shows an equidistant projection. And finally, we'll have azimuthal projections. These are also called true direction projections. It means directions of points are preserved with respect to center. Can be combined with any of the other three types of projections used for mapping of small areas only. This is also used for small areas, but the specialty of this projection is it can preserve your true directions. Something like this. And we will see the importance of data entry. So data source can be any one of the following. We can get the data from any one of the following cases by distinguishing from the map or scanning, traditional surveying techniques, paper records, field notes, GPS. These are different data source. The above data is stored in two interrelated databases. So all the data from the above cases will be stored in two interrelated databases. The first one is the spatial database and attribute database. In spatial data, it describes the location, shape, geographical features of the point. In attribute data, the data is stored in the form of charts, maps, or tables. It describes the characteristics or qualities of the special features. As we have already discussed about GIS, here we are going to discuss some of the uses of GIS to various fields in civil engineering. So it is used in environmental planning, management of national mineral and natural sources, emergency relief, transport planning, business applications, local administration, socio-economic development. So major applications in civil engineering. So GIS is having major applications in civil engineering. Let us discuss. The first thing is environmental planning. Providing effective analysis and modeling tools for environmental impact assessment. Air quality or water quality modeling and monitoring. So this can be done in environmental planning. Groundwater movement and modeling. Environmental hazard identification and its evaluation. This can be done uh, in environmental planning. Coastal management, waste disposal site locations, flood zone mapping. These are all the things we can do. And secondly, local and municipal authorities, where land use and inventory and planning, growth monitoring, cadastral and parcel mapping, this can be done. Census mapping and community development, planning and zoning, tax records management, engineering analysis, cross-section and elevation measurements of different areas. These are the things which we can do. And thirdly, transport planning. Here, fleet monitoring and navigation, corridor analysis, drainage and watershed management, highway design and customization, routine routing optimization and demand modeling, analysis of accident-prone areas, and try to reduce the accidents, analysis of road sections vulnerable to landslides, floods, etc. And finally, public utilities. So modeling community communications and distribution network. For example, electric power, telephone, gas, water, and sewer lines. Asset inventory and management, recreation and parks management. This can be done in park utilities. Now we will see different types of photogrammetry. Photogrammetry means taking a photograph for getting the detailed information or approximate information about an area. So it is nothing but surveying by taking photographs or taking measurements through photographs. It is called photogrammetry. Here we have different types of photogrammetries. Terrestrial photogrammetry. This is the first one. Terrestrial photogrammetry is an advantage over plane table surveying, as more details can be obtained from photographs and subsequent plotting can be done in the office. The terrestrial photogrammetry can be divided into two branches: plane table photogrammetry and terrestrial stereo photogrammetry. We'll see what is this. Plane table photogrammetry. Photographs are taken from 2 or 3 stations at higher points. The camera should be directed downwards. Area is then mapped. Using the photographs taken, the entire area is mapped. So this is plane table photogrammetry. Identification of image points in a pair of photographs is difficult in plane table photogrammetry. In such case, terrestrial stereo photogrammetry is a remedy. In terrestrial stereo photogrammetry, in this, the image points which are displayed relative to each other in two photographs are fused to a single spatial image. Hence, considerable improvement in accuracy. Instrument used is phototheodolite. So this instrument is used to take the photographs. The one advantage over plane table photogrammetry is it can fuse the two common photographs, and it will give you the single spatial image, where it is not possible with plane table photogrammetry. The instrument used in photogrammetry is phototheodolite. It is used for terrestrial stereo photogrammetry. It is a combination of 1 second theodolite and terrestrial camera. So 1 second represents its least count. So this is typical diagram of a phototheodolite. This just looks like a theodolite, which can take photographs also. So here camera is inserted where it can be used to take photographs along with the angles and measurements. You will see the parts of phototheodolite. A camera box is fixed focus type. It can be rotated with about a vertical axis. Hollow rectangular frame is inserted on right side. It has a cross-edge pressed against a sensitive plate and then photographed along with the field project. And we have straight transparent celluloid tangent scale, sensitized photographic plate for it, which gives us magnetic bearings, and there will be a support for the box supported on tripod. Here we have another concept, introduction to concept of stereo pair. The comprehension of depth is obtained by means of relative apparent size of near and far objects Effects of light and shade, simultaneous view of object by both eyes, which are spatially separated. The human eye fuses into one whole image by psychological process. The separate views of object by left and right eyes, and then we have a feeling of depth of the object. So we have different images when we see the two eyes. Our brain will fuse them and will give us a single picture. It is nothing but a photogrammetry. In stereoscopic fusion, a pair of photographs taken from two slightly different positions of camera is fused into one by use of an optical aid to provide combination spatial impression. The pair of such photograph is called a stereo pair, where two photographs are taken and the common portion is fused and entirely we will get a single picture. So this pair of where we use two photographs for a single picture, the pair is called a stereo pair. Stereoscope, an instrument used for viewing stereo pairs. Purpose is it presents a near natural vision and preserves spatial relationships, and it is used to magnify the perception of depth. Basic kinds of stereoscopes are lens stereoscope or pocket stereoscope and mirror stereoscope. So lens stereoscope, it is used and it has two identical convex lenses. It has two identical convex lenses mounted on a frame with inclined legs spacing between which can be slightly altered. Length of legs is less than the focal length. When focusing the eyes on the stereo pair using the stereoscope, natural vision of terrain is obtained. It causes strain for eyes. This is one of the disadvantages with this one lens stereoscope. So here, this is the portion where we can see the fusion. This is the common portion with left eye and right eye. So here it will fuse this area and give us a single picture. And then we have mirror stereoscope. Four mirrors at 45 degrees angle with plane of photograph. Outer pairs of mirrors are bigger called wing mirrors. Inner pair of mirrors are smaller called eyepiece mirrors. Stereo pair is placed below wing mirrors and stereoscopic vision is obtained in this. So this is a typical diagram for mirror stereoscope. This is called wing mirror. These are wing mirrors, means big mirrors. Here we have another type mirror, eyepiece mirrors also. This is the stereoscopic model after fusing the different photographs. This is nothing but eye base, the left eye and right eye, where we are seeing. The purpose of stereoscope plotting instrument is to, these are having high precision optical instruments used for reconstructing the spatial relationship at the time of exposure of a pair of photographs taken in terrestrial photogrammetry. In terrestrial photogrammetry, we may take different pictures from top angles where we need to fuse them to get a single picture so that we will get the information. In fusing those photographs, stereoscope plotting instruments are very helpful. The movement in horizontal direction of a floating measuring mark in the instrument is transmitted to a plotter pencil, which traces the map positions of the common and overlapping features appearing on the two photographs. Stereoscopic plotting instrument has four special components. So here, these are the components: projection system, viewing system, measuring system, and tracing system. This is the rough diagram for a stereoscopic model. Photographs are taken like this. and we will get a model, fusion model here on the map bar. Projection system has number of projectors, each with source of light, plate, holder, and lens, and it is capable of moving along and rotating about 3 coordinate axes to orient it correctly. The tracing table has circular disc with central pinhole. It can be raised or lowered. The tracing pencil point below the floating mass mark gives us the map position, and it is plotted on the map sheet. This is how the map projection is done. Here we can observe how two photographs are fusion together in lens stereoscope method or pocket stereoscope. So this is the common portion of left eye and right eye, where this portion is fusion to get a single photograph. Here we'll be having a single photograph. With this eye we'll be having another photograph, which will be fused to get a single photograph. So 4 mirrors at 45 degrees angle with plane of photograph. This is about a mirror stereoscope. Outer pair of mirrors are bigger called wing mirrors. Inner pair of mirrors are small called eye mirrors. We will see the diagram again so that we will get full clarity. So this is left eye and this is right eye from which we are seeing. These are wing mirrors and these are eyepiece mirrors. We are getting a single stereoscope model here. We are observing from the top and we are fusing the common details, and finally we are getting the mirror stereoscope, the stereoscopic model of the object. This is how we will fuse in mirror stereoscope. So today we have discussed different types of photogrammetry methods. What is photogrammetry? What is stereoscoping? What is stereoscoping of images? How we will do fusion of different photographs? What are the different methods for fusing the photographs? And these are all the things we have learned today. Photogrammetry means taking photographs through taking measurements through photographs. Stereoscoping is nothing but fusing different photographs already taken to get a single stereoscopic model for getting the information. So with this, we will close this session. So I hope we are having good session today, and we'll be continuing in the next class with another chapter. Thank you.